Hello everyone, in this video we will be discussing on the system design key concepts part 6, that is the rate limiting. In the prior videos we have discussed on the scalability, availability, cap theorem, acid transactions and consistent hashing. So we will be discussing on the rate limiting in this video. So firstly we will discuss what is rate limiting, different kind of rate limiting algorithms like token bucket, key bucket, fixed window counter, sliding window log and sliding window counter, and also what are the different standards to follow while doing the rate limiting. Then firstly we will discuss what is rate limiting. Rate limiting it helps the protect services from being overwhelmed by the too many requests from a single user or the client. That's called as a rate limiting. And what are the different rate limiting algorithms? First one is token bucket, second one is leaky bucket, third one is fixed window counter, fourth one is sliding window log, and fifth one is the sliding window counter. We will discuss each of these algorithms in the detail. So firstly consider the token bucket algorithm. This is one of the most popular and widely used rate limiting approach due to its simplicity and the effectiveness. How this particular algorithm works: consider a bucket that holds the tokens. The bucket has a maximum capacity of the tokens, and the tokens are added to this bucket at a fixed rate. Consider the 10 tokens per second in that way, and whenever the request arrives it must obtain a token from the bucket to proceed. If there are enough tokens, the request is allowed and the tokens are removed, but if there are not enough tokens available, then the request is dropped. And in this way this token bucket algorithm works. And the pros for this token bucket algorithm is it is easy to implement and understand, and also it allows bursts of requests up to the bucket's capacity, accommodating the short-term spikes. And the cons for this token bucket algorithm are: the memory usage scales with the number of users if it is implemented per user, and it does not guarantee a perfectly smooth rate for the requests. Second one is leaky bucket. How this leaky bucket works: it is somewhat similar to the token bucket, but it focuses on the smoothing of the bursty traffic. So consider the bucket with a small hole in the bottom. Requests enter the bucket from the top, and the bucket processes requests at a constant rate through the hole. If the bucket is full, then the new requests are discarded. So in this way this leaky bucket algorithm works. The pros for this particular algorithm are: it processes the request at a steady rate and preventing the sudden burst from overwhelming the system, and it also provides a consistent and predictable rate for the processing requests. And the cons of this leaky bucket are: it does not handle the sudden bursts of the request well. Excess requests are immediately dropped, and it is slightly more complex to implement compared to the token bucket. Then third one is fixed window counter. In this fixed window counter algorithms, it divides the time into fixed windows and counts the requests in each window. So how it works: firstly time is divided into fixed windows. Consider the 1 minute interval. Then each window has a counter that starts with the 0. New requests increment the counter for the current window, and if counter exceeds the limit, requests are denied until the next window. In this way this fixed window counter works. And the pros for this algorithm is: it is easy to implement and understand, and it provides a clear and easy to understand rate limits for each time window. And the cons of this algorithm is: it does not handle bursts of requests at the boundary of windows well, can allow twice the rate of requests at the edge of the windows. Then fourth one is sliding window log. So this sliding window log algorithm, it keeps a log of timestamps for each request and uses this to determine if a new request should be allowed or not. And how it works: it keep a log of request timestamps, and when a new request comes in, it remove all entries older than the window size, and it counts the remaining entries. And if the count is less than the limit, then it allow the request and add its timestamp to the log. and if the count exceeds the limit, then the request is denied. And the pros of this algorithm is it is very accurate, no rough edges between the windows, and it works well for the low volume APIs. And the cons of this algorithm is it can be memory intensive for high volume APIs, and it requires storing and searching through the timestamps. Then comes the fifth one, that is the sliding window counter. This algorithm it combines the fixed window counter and the sliding window log approaches for a more accurate and efficient solution. So instead of keeping track of every single request timestamp as the sliding log does, it focus on the number of requests from the last window. So let's say if we are in the 75% of the current window, 25% of the weight would come from the previous window and the rest from the current one. Okay, and how the weight will be calculated? It will be like 100 minus 75% percentage into last window request plus current window request. So whenever a new request comes, we will add 1 to that weight, and if this new total crosses over the set limit, then we have to reject that request. So how it works, it keeps the track of the request count for the current and the previous window, and it calculated the weighted sum of requests based on the overlap with the sliding window, and if the weighted sum is less than the limit, then it allows the request. In this way, this sliding window counter algorithm works. And the pros of this algorithm is it is more accurate than fixed window counter. It is more memory efficient than the sliding window log, and it smooths out the edges between the windows. And the cons for this particular algorithm is it is slightly more complex to implement. While having this rate limiting, we should follow the certain standards. Like while implementing the rate limiting, we should consider factors such as the scale of our system, also the nature of the traffic patterns, and the granularity of the control which we need. Sorry. Also, we should communicate the rate limits clearly to the API users, preferably through the response header, so that they can implement appropriate retry and backup strategies in their clients. Thank you.